Live from Earth. Oh, what is going on? I am super jacked up here in audio. Wow. So many fun issues tonight. So let's bring that down. Wow. So this is going to be a different kind of episode. Yes, you should be hearing me. And I should be okay. But let me know if things are funky. And I will keep adjusting them because this is all I got. This is all I got is you. I can't hear myself. I have no idea if I sound good or not. This is going to be a different space radio. So we were supposed to have a guest, Paul Geithner, representing the James Webb Space Telescope. Yeah, so like his namesake project, he's a little although no fault of Paul's. I'm sure we actually confirmed. Nancy confirmed with it. I don't know why I say we. It was Nancy all along doing the work. We confirmed with Paul just yesterday, I believe. But there are massive storms rolling through the East Coast, and he probably got caught up in that. So we will try to arrange to have Paul on again. What this means, though... What this means is that I have no plan. I have no plan because I didn't prepare anything because I was going to interview Paul Geithner and we were going to talk about the James Webb Space Telescope. But Paul's not here. This Paul is here. There was another Paul. I know that can get confusing with multiple Pauls. That Paul is not there. This Paul, you're going to have to settle for just one Paul tonight. You're not going to get two Pauls tonight. I'm sorry. But listen, this is Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your agent to the stars. This show lives on listener questions, especially this episode is really going to live on listener questions because I've got nothing. I mean, that's not much less than normal, but this time I mean it. I've got nothing. We record every Thursday at 8 p.m. Eastern here in Spaceman Studios in New York City. So to get yourself on the air, you need to leave a voicemail. Go to spaceradioshow.com for the links. You can also follow along live with our Space Cadets, tuning in live from around the world. Listen, this is going to be a very casual show. This is going to be a very low-key show. This is going to be a lot of questions. Please, Space Cadets, start tossing those questions at me because without the questions, I'm just going to start rambling and ranting, and nobody wants that. We got questions. Most of the questions were geared towards Paul Geithner about the James Webb Space Telescope. I'm going to go ahead and answer them. What would be fun is if I answer them and then we get Paul back on the show when tropical storms are not slamming the East Coast. I know where we're prepared. We're going to get hit tomorrow. So it's a good thing Space Radio doesn't record on Fridays because you probably wouldn't get a lot of Space Radio. And then compare the answers to what Paul got. And you can do a Paul v. Paul comparison and see which is better. I'm sure they're both largely correct. I'm sure Paul Geithner's answers will be more correct than mine. But maybe mine will be more entertaining. I don't know. We've got a YouTube Space Cadet here. Could China steal the JWST? JWST is the James Webb Space Telescope, like in the James Bond movie, You Only Live Twice. No, you're not stealing satellites, especially the James Webb. This James Webb is not going to be in orbit around the Earth, which is one of the reasons that this is such a nail biter. Because the Hubble, remember the Hubble went up and it turns out, oopsie, there was an issue with the Hubble. They didn't grind the primary mirror exactly right. There was a mistake in it and it made all these infamously blurry images. But we were able to send up a space shuttle mission, give the Hubble some corrective optics, and away we went, and Hubble has delivered 30 years of science, although the Hubble, I believe, I believe, is still down as of right now. It's been down for a little over a week now, and it's not looking too good. Now Hubble has had a lot of near misses before, but this might be it. But we're not quite thrown in the towel yet. But nearly 30 years of science with the Hubble. With the James Webb Space Telescope, it's not going to be in orbit around the Earth. It's going to be like millions of miles away. It's going to be at a Lagrange point, which is a point in space where the gravity of the Earth counterbalances the gravity of the sun and everything's cool. You can hang out there. It's a pretty stable place to be in the solar system. The reason the James Webb needs to be so far away from the Earth is that it is an infrared telescope. It studies infrared light coming from across the universe. And the Earth, being somewhat warm and getting warmer, emits a lot of infrared radiation. So if you put the James Webb right next to the Earth, it will be too hot. There'll be too much infrared light coming from the Earth to allow us to do some really, really cool science, the kind of science we want to do. So we need to put the James Webb far from the Earth. It's got this massive sun shield to block a lot of sunlight, because the sun also emits a lot of infrared radiation, as you might have noticed on a warm, sunny day. And it has also cooling elements, so it has a limited lifespan. It's not going to be like the Hubble where it can just keep going and going and going. Once it runs out of fuel to run its cryogenic systems to bring the temperature of the instrument down so it can absorb infrared, it's done. No one's stealing it. The James Webb is going to go to the Lagrange point, and it's going to stay there, and it's going to have a great time for like 10 years. And then that is it. Whew. What else do we have for the other Paul? Is James Webb going to launch in 2022? So it's currently slated for October of 2021. So far, James Webb has passed all of its checks. Finally, it's only like a decade late. But this is the big problem. It's going to launch on an Ariane 5 rocket. And Ariane 5 has been an incredibly reliable rocket for decades, but the past few launches, there's been some extra vibration that should not be there. It hasn't affected any of the missions. It hasn't affected any of the payloads. But when you're launching a once-in-a-lifetime telescope, the last thing you want is some extra shaky. So there's a few more launches of the Ariane 5 of the same kind of rocket, obviously not the exact same rocket because these are one and done style rockets, but of the same kind of rocket. And when that launches, you don't want extra vibration. So we're monitoring the upcoming launches. I believe the James Webb is the third upcoming launch of the Ariane 5. And then if the next two play nice, then we're golden. We're golden. And so we'll see. Is it going to hit October of 21? Let's just say I'm not putting any money on it. I'm not putting any money on it. If it actually gets up in 2022, I'm going to be really excited for it. Next question, will James Webb be able to detect, this is from Wes Strubing on YouTube, the Space Cadet, will James Webb be able to detect exoplanets that don't occult their stars? These are exoplanets that cross, the method we use to identify the vast majority of exoplanets is the transit method, when the planet crosses in front of the face of its star. That is how James Webb is going to operate. James Webb isn't going to be very much of an exoplanet discoverer. That's more up to missions like TESS, the Transiting Exoplanet Survey Satellite. That is an exoplanet hunter. TESS is finding really, really good candidates for follow-up observations with the James Webb, with the better optics, with the infrared, with the higher resolution, with the more data, to potentially find habitable and potentially habited worlds. Moving on. Ooh, Alex, I'll go ahead and answer this. Oh, hi, Paul and Paul. That's the two of us. Given that James Webb can see into the nebula clouds beyond the dust and gas that usually blocks our views, what are you most excited to see in this unknown space? So James Webb is going to be a great instrument for watching stars form, watching planets form, watching planetary systems form. And that's because when stars form, when planets form, there's these massive layers of gas and dust that envelop these embryonic systems. And the gas and dust blocks visible light. So to us, it just looks like a big black blob in the sky. But actually going on underneath is really cool star formation. But infrared radiation makes its way out of the gas and dust. And so by studying in the infrared, we can watch these systems evolve and play out. And we can look at different kinds of systems. So we've had the general picture of star formation and planet formation for quite a while. But this is going to be much better. James Webb is going to present unprecedented views in the infrared of these kinds of processes. And it's just going to be fantastic. We're going to watch baby stars form. We're going to watch baby planets form. Not necessarily in real time because it kind of takes millions of years, but we're going to get to see it at a level of detail and a level of resolution that we simply haven't had before. So James Webb is going to be a fantastic instrument. Brian is asking, how does James Webb point at targets? Is the reflector always perpendicular to the sunshade? Yeah, there's a lot of leeway in how the James Webb can point, but it also has to wait for certain different parts of the orbit. So it will be orbiting the sun just like the Earth is, and certain targets will not be available to it because at certain times of year, because it will be in the direction of the sun. It has to wait half a year in order for that part of the sky to be where it's looking, and then it can move around a little bit to target. What are we hoping to discover with James Webb? Because it looks beyond visible light. I know James Webb is being called a successor to the Hubble, but it kind of sort of is. But Hubble was primarily a visible light instrument. Hubble was primarily an instrument for taking photographs, for taking pictures of visible light, and a little bit of infrared. The James Webb is going to be a very different beast. The James Webb will be almost entirely infrared. That means the pictures that it takes of objects in space will not be the kinds of pictures that you could see with the naked eye. These are not the kinds of pictures that you can get with a backyard telescope. It is a different frequency of light. And this was chosen. There was a lot of work that went on into what is the successor mission to the Hubble? What should it look like? And in the vast array of astronomy, of all the different wavelengths we can use to study the universe, the NASA, the mission designers were asking, what has the biggest holes? What has the biggest gaps? What could really benefit from a next generation infrared telescope? And we've had infrared telescopes in space before, most notably the Spitzer infrared telescope. This is like Spitzer on steroids. This is Spitzer plus. You are definitely going to see some amazing pictures coming out of the James Webb. And these pictures will represent real information, but it's going to be translated into the visible spectrum so that we can get a better handle on it. Just visually. Most of the information, the vast majority of data processing, the vast majority of analysis will take place purely in the infrared. And sometimes when we want to see a pretty picture, we'll do some mapping from infrared wavelengths to visible wavelengths so we get a picture. So keep in mind when these amazing pictures from the James Webb come out, that this is not a visible light picture. That has been colorized. This has been translated from the infrared to the visible. Now that said, why infrared? Why does this have the biggest gaps? Well, because there's a lot about the universe that we would really like to know where infrared is especially juicy. Number one, star formation and planet formation. You get a lot of information from the infrared, and infrared is kind of tough from the ground because we have our atmosphere and we have our warm earth. And so infrared telescopes are always going to suffer on the ground a little bit. We like putting infrared instruments in space. We had Spitzer. We'd like some more. Another thing is what I mentioned, the exoplanets, and especially the habitability and studying the atmospheres of exoplanets, studying those atmospheres, looking for spectra, looking for elements, looking for molecules. A lot of the really cool action, let's say, I don't know, oxygen, happens in the infrared. So if you have an incredibly powerful, high-resolution infrared telescope looking at planetary atmospheres, you have a better chance of finding habitability than you do with just visible light telescopes. And lastly, we are going to be studying with the James Webb the very early universe. The very early universe, we are going to be targeting the first generations of stars, the first generations of galaxies. We are going to open up this frontier. We've over the past 10 years, we've been making like little encroaches, little headways into the epoch of the formation of the first galaxies. The James Webb is going to be like a spotlight on that. It's going to be so much more powerful. It's not a wide survey. It's not going to get us millions of galaxies, but we're going to get distant galaxy, distant galaxy, distant galaxy, distant galaxy. We're going to get a lot of information about a lot of galaxies. And the reason infrared is useful there is that these galaxies are so far away that even though they are emitting visible light, by the time that light reaches the Earth, the universe has expanded so much that it's redshifted that visible light down to the infrared. So if you want to look for distant galaxies, even though all those stars in those galaxies are shining in visible light, you don't want an optical telescope. You want an infrared telescope because they are so dang far away that the expansion of the universe has carried all that radiation down into the infrared. So that's the three main science areas. It's exoplanets, it's star formation, it's early universe. Those are the three primary goals. There are dozens of other goals. We will be mining James Webb data for decades to come. Just like we still study archival Hubble data, there are people who write entire PhD dissertations based on archived Hubble data. They don't take fresh observations. They just dig through the archives and find something interesting. We will be finding interesting things from the James Webb for many, 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 many years. Hopefully enough to make it worth the investment, but that's not something we can predict right now. I just want to remind you that this show is brought to you by you. Please go to patreon.com/PMSutter to learn how you can support this show. That's patreon.com/PMSUTTR. You can also drop a super chat into the live chat anytime if you are watching right now. I truly do appreciate it. Kento is asking about the shirt I'm wearing. Are those bacteria or viruses on your t-shirt? Neither. They are leaves. They are leaves. But I guess I'm seeing what you're seeing now, and I could see how they could be interpreted as little bacteria. But no, once you get up close, I'm looking at it right now, it's just a whole bunch of leaves. It's a very tropical vibe shirt that I'm wearing today. Tom Vassos, I can't wait for the James Webb Deep Field. Yeah, we're going to get some truly stunning images, but remember, the James Webb, this is fascinating. The James Webb has a hard time seeing nearby galaxies. Yes, nearby galaxies do emit in the infrared, and we will be able to detect them with the James Webb, but the James Webb has a harder time because the infrared emission from those galaxies isn't too strong. It's better, it's tuned, it's targeted for those high redshift observation. Ferns, Wes is telling me that they are ferns. Well, don't ferns have leaves? I'm not necessarily incorrect, right? Ferns have leaves, grasses have leaves. Yeah, Kento is asking if space redshifts light. What happens to light that started out as far red and traveled 40 billion light years? 40 billion light years, I don't have like a redshift calculator in my head, but you can just keep going redder and redder and redder and redder. And past infrared, you get down into the microwave. Past microwave, you get down into the radio, and then deep radio, and then we don't bother classifying it anymore. It's just very, very long wavelength radio. So it can just keep going all the way up to where the wavelength is the width of the entire universe. That's how deep you can go. For example, the cosmic microwave background started out as visible light and shifted all the way down into the microwave. So it went from wavelengths of, a few hundred nanometers to a wavelength of, like yay big. That's how far it went over the course of 13 billion years. Arnetta is asking, do you think NASA will be able to repair Hubble? I don't know. It's too early to call. I know they're really trying hard, but it's going to be a dicey one. I hope Hubble recovers after this because, man, now would be the perfect time to get that James Webb up there, get that first light and get this science mission going. Hubble is hanging on by a thread and it's currently inoperable. I hope it just doesn't turn into another piece of space junk. I just released a video today. Yesterday. I released a video yesterday about space junk and how it's ruining space to coincide with my podcast episode on the same subject. So check out this channel, youtube.com/Paul M. Sutter. Check out that video on space junk and how we're ruining space. We're making space worse and it really stinks. Like, yeah, it is possible to pollute pure vacuum. And you know what? Humanity figured out how to do it. And all the solutions we have to tackle space junk aren't that great. Alex, what new physics can James Webb? I'll assume all these questions are now for me. I'll possibly discover that you're most excited about. I'm a cosmology guy. I love cosmology. I did some work in the cosmic dawn, in the age of the first stars, the first galaxies, developing some data analysis methods for future observations of that epoch. So I'm excited for the James Webb to really try to unlock this. We do not have any sort of observational picture of when the first stars lit up, when the first galaxies lit up. We have so many questions. How did the first stars form and evolve? How did the first galaxies evolve? How did the first giant black holes evolve? How was it all related? How did they interact with each other? Was it all normal, everyday, modern day physics, but just ramped up to 11 with bigger stars and very rapid processes? Were there more exotic things going on? Was like dark matter collapsing to form black holes in the first stars? Was something even more interesting happening? We don't know, and we won't know until James Webb tells us, and other instruments to go along with James Webb. Infinite Monkey is asking, are binary stars hostile to life? Maybe, maybe not. It's certainly possible to construct a stable binary system that can have planets. Planets can orbit stably in binary systems and multiple systems. In fact, we know of one example, our nearest neighbor, Proxima Centauri. Proxima Centauri is part of a triple system. There's Proxima Alpha and Beta, Alpha Centauri is a binary star. In the binary stars, these two stars orbit each other very, very closely. And then very, very far away from them is a red dwarf that orbits that entire pair. That red dwarf has a planet we call Proxima b. So right there you have, and Proxima b, that planet is in the habitable zone of that red dwarf star. So right there you have a habitable planet in a triple star system. Now, can you get a situation like Tatooine from Star Wars where there's double sunsets and all that? Yes, we know of exoplanets around binary systems where the planet orbits both stars. Yes, you can have a habitable zone there. Yes, it gets a lot more complicated, but no, it's not out of the question. And since like half the stars in the galaxy are members of binary systems or more, and there's a lot of planets out there, I don't know. It certainly makes things more difficult because you have two things that can blast deadly amounts of radiation. There are more chances for unstable orbits and can get a little bit nasty, but it's not totally out of the question. Let's do some cheese. While I'm talking, today's cheese is, you hear me sliding that cheese plate over, by my good friends, my great friends, my amazing friends at Dom's Cheese. That's DOMScheese.com. DOMScheese.com. They are fantastic people, and they gave me an amazing looking cheese, Beemster XO. This is a Dutch cheese. It's a Gouda. It's a super aged Gouda. Look at that. This guy, oh wow, has been aged for 26 months. That is a Gouda. It's cow's milk, hard cheese that has been aged for over 2 years. And the fine folks at Dom's told me you don't bother slicing it, you just break it off. You just break it off because it's so hard, and they're right. You just break it off. Very crumbly texture. Apparently the tasting notes here, it's a robust cheese with notes of whiskey, butterscotch, toasted pecan, and deep caramel. It's like I'm eating am I about to eat a pecan pie in cheese form? Or should I say a pecan pie? I don't know. You get the crystals in there, so that there's this little bit of crunchiness. You get this blossom of flavor. I taste the whiskey. That's so fascinating. I've never tasted a cheese like that you get like a little bit of alcohol notes. Not like alcohol, but if you've ever smelled whiskey, when you eat it, this cheese, this Beemster, it's like smelling that whiskey, and then some like sweet, subtle butterscotch. It is nothing at all like a pecan pie, or a pecan pie for that matter. So that's wrong. This is its own thing. It's its own creature, and it's just, the flavor just like blossoms and coats your mouth. It's just like candy. This is like really, really, really fun candy. And like candy, I can totally overindulge. I need to stop. For now. That's Beemster XO. Aged for over 2 years. Man, I'm going to have some more of this. It suggests here food pairings of like olives, fig cake, spice honey, roasted nuts, honeycomb. You don't need to pair anything with this. You just eat it. It's like a whole package. Like it's like an entire meal. It's that Willy Wonka like entire meal in one piece. Like you get the cheese and then you get the dessert. All it's missing is the mashed potatoes. So, unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Please visit patreon.com/PMSutter to learn how you can contribute. Thanks to Nancy Graziano for producing the show, wrangling the Space Cadet, and attempting to get our guest. But I look forward to chatting with Paul Geithner in a future episode. And catch the live stream. But how perfect is it? The guy who's going to talk about James, you know where I'm going. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for more info, links to the live stream locations. You can also follow me on all social channels. My name is @PaulMattSutter. And of course, thank you again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission.